building services described as providing services that make building operational, comfortable, clean, efficient, and environmental friendly. Building services play significant roles for power consumption, including space heating or cooling, domestic hot water, and electricity. It exposed to high noise and lighting. So, acoustical and lighting system is important to promote comfort for human. The task for this study is to propose the acoustic and lighting design for auditorium hall. The objective for this study to investigate the noise level and lighting system, to conduct measurement on different points in the auditorium, lastly to determine the suitable design for improving acoustic and lighting system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nursyahada Miti Muhammad Zilani. I will be presenting about the acoustic design in an auditorium or concert hall. For the calculation in acoustic design, we need to calculate the reverberation time and the room modes. The size of the hall is 33.45 meter length, 25.5 meter width, and 10 meter height from the floor to the ceiling. The material used is a concrete floor with the sound absorption coefficient value of 0.02 and painted brick wall with the sound absorption coefficient value of 0.02 and plasterboard ceiling with the sound absorption coefficient value of 0.09. For the reverberation time, this is the formula used, and we get the value of reverberation time of 11.68 seconds. This means that it takes 11.68 seconds for the sound in the hall to fade with time. In a more reflective room, it will take longer for the sound to disappear, as it will reverberate around the hall. So, we need to place an absorber to enhance the acoustical performance in the hall. Next, for the room modes natural frequency, this is the formula used to calculate the frequency of room modes. There are three types of room mode used, which is axial, tangential, and oblique. The formula here, F stands for the frequency of mode in Hertz. C is the speed of sound, which is 343 meter per second at 2 degrees Celsius. The Nx stands for the order of mode of the room in length, while the Ny stands for order of mode of the room in width. The Nz is the order of mode of the room in height. The L here stands for the length, B is for the width, and H is the height. The calculation of the frequency, the analysis of the frequency need to be made until 250 Hz. For the axial room mode, the data is 0014 and the highest frequency is 240.10. For the tangential, the data is 14014 with the frequency of 250.6. And for the oblique, the data is 13, 13, and 13, and the highest frequency is 249.2. That's all the calculation for the acoustic design. Thank you. Assalamualaikum.
So for the wall, we are choosing two type of absorber, which is, for the first one is porous absorber. There are three types of porous absorber, which is glass fiber, rock wood, and also open form. We are choosing the rock wood because it is the most effective material for the noise control. And then for the second one is a panel absorber, is also known as a membrane absorber. Membrane absorber is able to create an optimal sound environment and also can reducing the echoes. And then for the shielding, we are decide to install the acoustic reflector and also diffuser. The function of diffuser is a treatment of stopping the sound bouncing off the various surface of the room. It is effectively reducing interfering reflection in any one particular direction. So for the reflector room shape, we are placing 5 speaker and 4 porous absorber and also 2 panel absorber. This type of 3 projection is normally achieved by a high and also reflective shielding that will accomplish effective projection of the sound.
For this building, we are going to use a fluorescent tube, which is 1500 mm long with 32 watt power. When designing this, referring to the luminous vector for painted surfaces, we assume that the luminance vector we're using for studio, since it is an enclosed large area. So the luminance vector for white ceiling is 70 to 80%. We are assuming 70%. And the luminance vector for the dark grey wall that we're using for the interior of the hall, we are going to use 30%. So we assume that these buildings have a high maintenance factor. So we are going to use 0.9, and the height above working plane, as the height of the building is 10 meter, so we are going to use 9 meter for the height of the fitting above working plane. After calculating the number of required rows along the width of the room, we got 9 rows, and the total number of luminaire in each row is 20 fitting per rows. This is the layout of the 9 rows of 20 fitting, filled with 2 1500 millimeters of fluorescent tube in each fitting along the room.